Hi, and welcome to the online version of this CAD workshop. I'm Keith, I'm the tech lead at EMU Robotics, and you would be watching a recording of a live stream right now, but when I tried to do this all at once in the lab, everything backfired, students had technical difficulties, I had technical difficulties, and all the audio was ruined. So here we are. Even though this is running online, I am still going to bring up some factors that I wanted to do during the in-person. And that's that even if you're watching a video, please watch this video with someone else who is also learning CAD. It makes it a lot less tedious. My biggest fear is that you're going to get like 10 or 20 minutes into this and you're going to go, this sucks, Fusion 360 has too many buttons, and give up. Because that's how it quite often goes. This is just for online people. All of the students, it should be in the Google Classroom. So, this is an overview of what we're going to be covering today. You should be able to make any assembly with roughly these 5 steps. And I'll take a 3-second pause for you to guess what these 5 steps are called. So this one, unsurprisingly, is sketching. You see all those like funny dimensions and stuff? That's the sketch workspace in Fusion. This one here, unsurprisingly, is a body. Or maybe surprisingly if you've never done CAD before. This one is components. So we make a sketch, we'll turn it into a body, and then we need to handle all of our different files. Once we've turned our bodies into components, we can then drag them into an assembly. And then from an assembly, you can make relationships between joints in an assembly to using motion links to make them move and to actually help you understand and check that all of your moving parts work in practice. So this is a CAD model that I've designed specifically for this workshop. And as you'll briefly see, let's do some OBS magic. There we go. Is it actually, I think, yep, there, okay, cool. So this is the model. You can see I've got it here in Fusion. Yeah, it's taking its sweet time. And it already looks kind of funky, like, whoa, there's a lot of detail there. We'll learn how to do that detail. But the most important part that I want you to take away from this workshop is being able to make models that can behave like this. And it's not just like one part. I can click on any part of this mechanism and it all behaves. And it might look kind of scary right now, but I assure you, once we get through it, you'll see that it's really not that bad. So why do I have a textbook on the screen? That's because if you're an engineer, CAD is pretty as close as it gets to an essential skill as reading and writing. Whether you're on the technical team, unsurprisingly, you're going to need to design parts, or the robot will not exist. But even if you're doing more impact side work, or you're on media and you're handling posts and like marketing for the team, you need to be able to access CAD models and navigate through them, make renders, and get what you need from the other teams without having to rely on someone else. And quite often you'll find, like, even if you end up being a machinist, you need to be able to access these CAD models. Where is it? I'm going to do another transition. Oh, you need to be able to access these CAD models so that you can get dimensions for these parts, so you can manufacture them. You'll find once you have the skill of CAD, it crops up everywhere and it will pay off 10 times over. So obviously I just gave an overarching big picture view of why CAD matters. But this is more relevant like in the short term. Who knows what this funny looking fridge is? If it's one of my students and you actually are from the team, you might have remembered when I took you on that tour around the UNSW makerspace. And you might remember something that looked vaguely like this. Well, this and this like funny looking washing machine as well, they both have something very important in common. Now I will clarify. So this is a laser cutter for those who don't know, and this is a CNC machine. They both have something in common, which is really, really essential. And that's that we need to use CAD if we want to use these. These two machines, and in reality, just about any other machine like 3D printing, metal laser cutting, which like that machine would like take up the whole screen, so I can't put it on there. To access any of these, you need to have a CAD model to work off. The alternative is you can sit at that little control panel there and you can type in numbers to your heart's content and be there all day. But we don't want to do that. I don't want to see jigsawed models which are covered in metal burrs and holes which aren't drilled square. This is the solution to making things quickly and accurately. Laser cut wood also really smells nice, and I appreciate that a lot. We're going to be working on Fusion 360 today, but I think you'll find once you've mastered any one of these, if you sit down for 3 hours in, say, Onshape or SolidWorks, you will be able to get pretty close to your standard level of productivity in the other software. The most important thing about CAD isn't so much that it's very similar to coding in the way that you're not learning a software, you're learning a way of thinking and like problem solving. You're learning a way to understand a design and then convert it into a like 3D model. And I speak about this from experience. I've learned SolidWorks and Onshape, not to the same degree as Fusion, as you'll soon see, but I do have experience in them. And while this is something our team doesn't use that much currently, it is something I would like to work on and training up students in the future. It's kind of impossible to get to the stage of finite element analysis, that's what FEA stands for, without having CAD models. You need a computer model for the computer to do maths on your model. Kind of makes sense. And why would we care about FEA? It's so that we can reduce the weight of our robots, have them be faster, save material, being more economical, saving money on material. There's a myriad of reasons. If you're watching this in the year 2030, you can ask your chatbot assistant and it will give you many more reasons than I can list off. So, before we get into the teaching part, why should I be the person to teach you? I have a decent amount of experience. I've been doing Fusion 360 for about 2.5 years. This is a assembly model that I made in 2024 for EMU Robotics. I was still like a student then. I hadn't aged out. And I did this full assembly as my second season of FIRST Robotics. Funnily enough, this assembly and something else you'll see later was good enough that I was able to get a job with the uni. And somehow like Fusion is about 60% of the hours that I get paid for. I am in CAD, I am using these skills that I'm about to teach you. And here you can kind of see the process. We make a digital twin. And digital twin is something you'll kind of hear me emphasize a bit. Maybe not in this workshop, definitely in the lab. And it gets made in reality. And it only has to be made once because we figured out all of the funny mess ups in CAD. It's much easier and cheaper to fail fast in CAD than it is with physical items and expensive material. This is another project that I made. This was a sumo bot for a uni competition. And you can see here, this is a little gearbox that was used for the sumo bot. It was for a little radar system. And here's the actual sumo bot running around. So this was about
it's munching it.
50. Oh wow, yeah, I have all the audio coming through on my laptop. Sorry about that. This was a about 50-hour CAD model, and then it took 25 hours manufacturing and 25 hours coding. We don't need to worry about the coding side here. It's mostly the CAD and the manufacturing. Let's get off that. And this was a uni project. I did this full CAD model as well. So you'll see this skill that I learned in high school is very quickly paid off in uni with both grades and a job. And of course, I've seen, as you've seen, I do have some experience, but I have never had formal training in Fusion, so I am obliged to say this. I don't actually know what I'm doing. If you're building bridges, or maybe you work at NASA, or you're making rockets, probably don't trust this workshop. Might not be for you. You might be a little bit too advanced for it. Otherwise, go ham, knock yourself out. So, this is what Fusion 360 looks like. I know, lots of buttons and lots of lines. This thing here in the middle is kind of scary. I don't know what's happening there. And there's like, I don't know what all these things along the top are. So we can kind of break it down. So this main space, this is where you spend all your time. This is where you make things. This space up here, this is where all of your, let's use a pencil case analogy. This is where all of your pencils are, and this is where your paper is. You use your tools up here to make your work down here. And just so, and something I would like to clarify, I'm going to quickly pop into Fusion for this, which is going to take a 10-second juggle as I jump around between scenes. There we go. Juggle is still happening. Okay, we are now in Fusion. Something that I know people quite often struggle with is that they'll be in this workspace, and then they'll like say, oh yeah, say I'm sketching, and I'm trying to make a sketch. I'm jumping ahead here. I'll explain this in a bit. And then you'll click here. So where have all my sketch tools gone? I have no idea, and I'm never going to be able to find them again. I'm going to spend half an hour trying to find out what this is, and then I will give up and I'll quit Fusion. So just to clarify, this little workspace where we have all of our tools up here is able to change. It changes depending on what space we're in and what we're making. Let's go back to, oh, there we go. Juggle is going smoothly. This one, cool. So we've done our working space, and we've got our little tools to make things. Up here and over there, that's where your files actually live. There's only one difference between this area and this area, and that's because this area is like your file explorer. And oh, it looks like my camera is lagging out. That's great. And this area is all your currently open files. And so, like, unsurprisingly, you can see up here, I have like one there, one there, one there. It's actually hidden behind my webcam. What can I do about that? Oh, let me just turn off the webcam for a second. Oh wait, no, it's on a different scene. Let me go here and then turn off the webcam for a second. There we go. There's a little plus there. That's where you make a new model. And then these are all the currently open models. Okay, let's speed up a little bit. Now, what we're going to do first, we're getting close to the stage of making things. I'm going to bring back my face for a second and then it'll disappear. So we are going to make a new folder. We're going to be doing all of our work in a folder. Oh, that's out of order. Probably should have mentioned that sooner. Okay, I'm just going to show you how to make a folder first. Let's go to here, and I'm going to hide these two. There we go. Actually, can I keep my face on the screen? I can keep my face on the screen. Fantastic. Cool. So what we're going to do here, now generally you'll have to be in your own project. So you'll have like one of these. In this case, I'm just working in our Emu hub. I think that's the technical term. And I'm going to make a new folder. So new folder, CAD, workshop, folder, enter. And I've double clicked to open it. Cool. Now, before we do anything else, one more thing I want to clarify. You might be kind of confused right now because your CAD doesn't look the same as my CAD. On my screen, you can see down here, I can click around here and change the way that my Fusion 360 looks. This menu is bugged out really bad, so I'm going to quickly resize that, see if that fixes it. No, it's still very broken. That's lovely. And it's made the camera... Okay, this is great. It's made the camera setting unaccessible. Let's... All right. I'm just zooming up for this one part so you can see this. Under here, you'll see there's different options. When I click on the screen and I can go to camera, I can change between perspective and orthographic. That doesn't matter to you now. I just want you to know that there are different settings in here. You can play around in your own time and see what changes things. The main thing that might confuse you during this, there are different environments. And depending on those environments, you can see how the background changes color. And also your lines will change color. So on the screen right now, you can see how I have like white lines and blue lines and green lines. If your lines are different colors, like if you have black lines and like orange lines, that's probably just because your environment is different to the one I'm using. In this case, I'm using River Rubicon. Cool. So let's make a really basic model. Yeah, so you're going to have this workspace open. You might have lines like there is on the like example photo I have, or you might not. I'm not sure what your default settings are. What we're going to do is we're going to click on this Create Sketch button up in the corner. And then you'll see these three squares show up. What we're going to do is, I mean, realistically, you can click on any of them and it'll automatically change it. So you can see, like, I click on that one, it'll bring me until I'm like looking flat against that face. I'm going to press Control Z to undo that. I'm going to click Create Sketch again. You can see I can click on another plane. It'll bring me to face it. Control Z, I'm going to undo that. I'm going to click Create Sketch one more time. And this time I want to show you an important navigation skill that you're going to need. You'll notice down here how there's pan, look at, and orbit. These are very, very important to navigating around Fusion. If you want to be using it and not looking a little incompetent, like say your employer's looking over your shoulder and you're not orbiting around your model and you're just using the cube in the corner, that might be a little embarrassing. So we're going to do it the proper way. I can use middle click to pan, and I can hold down Shift and middle click to orbit. And now with that, I can move this until I can see which face I want to click on, and now I'm going to click on it to create sketch. So now that we're in the sketch menu, there's a few different tabs up here. If you're working on a smaller screen, you might see less than this. You might only see like one or two icons for each tab. In that case, you just need to click the drop down and you'll see them show up. All we need to worry about for now, out of all of the buttons on this screen, is this little create area here in this rectangle. So I'm going to get you to use the line tool, and then you can click to place around. Super basic. I'm going to set a 2-minute timer, and I just want you to mess around with everything on here, because I could sit and explain it to you, but that would get really boring for both you and me. And I think this is a more fun way to do it. Where is it? I'm going to, transition scenes again. There we go. 2-minute timer. And go. I want to see you making all sorts of scribbles. I'm going to be quiet and working away. Minimize this tab. Go make scribbles. "50 seconds remaining." And time is up. Oh, no, time's starting again. Okay, there we go. There is now one button on your keyboard that I need you to press, and that is the E key. So you don't even need to have anything selected, and I'm going to randomly press the E key on my keyboard. And you'll now see this menu that's come up that says extrude. What do you think extrude does? Talk to yourself, or talk to your partner if you actually have people around you. Or, I don't know, talk to someone in the lab, or send someone a message. What this tool does is you can select an area. I just clicked on that. And then you can type in a number, let's say 10, and it will extrude it out. And put in like 50. And wow, look at that. So I've made this little like block now. That's pretty cool. Let's say I want to make another shape from my sketch. So I'm going to press Control Z for a second just to like go back to my sketch. Let's say I want to make this like little like half donut. So I'm going to press Control Y to redo. Where's my sketch gone? I can press E to extrude, and I've still got that menu up, but there's nothing I can click on. So what Fusion sneakily does is that even though, so I'm not sure if you've noticed this browser menu up here. You can see how there's sketches, bodies, and then other stuff that we don't care about. Even though sketches is visible, your sketch is actually made invisible inside sketches. And so that little eye icon there, we can click on that to bring it back from being hidden. You can see how like clicking on this changes, like brings it up. Get familiar with that. Click it like 10 times until it clicks in your brain and you're like, wow, this is amazing. Cool, so I've now, I'm just gonna quickly press escape to go out of everything. And oh, my sketch is gone. Okay, so I'm going to click highlight on my, I'm gonna like make my sketch visible. And then I can press E, bang, I've pressed E. And then I can click on my profile and drag on this little arrow. I can like click and drag on this. You can see I can put it in any direction and it is brought into existence. There's also a whole bunch of other little like doodads you can do with this menu that are really cool. but that's probably gonna be really boring if I talk you through all of it. So you can just mess around and press different things and go, oh wow, that looks cool. I'll mess around with that later. And yeah. So I guess that means we've now finished the first two stages and we're ready to take on a like big scale like model, right? So like you fully know how to sketch and make bodies, and you're ready to do like engineering drawings like this one up here, and then make this cool part, right? Uh, right? No, I'm just kidding. This is the part where we actually go into sketching for real. So, I'll this is quite a large jump. Normally, like even at university when they're teaching this stuff, they do 2 hours on sketching and then 2 hours on bodies and then 2 hours on drawing. But quite frankly, I don't think you, who is statistically probably a teenager, have the patience for that. So I'm going to do trial by fire. Just before I do trial by fire, I'll show you how I would do one sketch, and then we'll see how you go, and it'll be interesting. The reason why I'm doing trial by fire is because you might have a large variety of skill levels. I want this to cater for everyone. So if you don't have that many skills, chances are, if you're in FRC, you probably know someone that does have skills. Do this while you're in the lab and ask questions anytime you get stuck. The worst thing you can do while facing this trial by fire is getting stuck for more than 5 minutes. Seriously, like have a mental timer or have a physical timer. And if you're stuck on something for more than 5 minutes, ask someone or start searching or ask some sort of language model. Cool. So before I do the trial by fire, I'm going to work through a really basic sketch. When I was in the lab, I actually got the students to like kind of hand on heads for this part, so that everyone is just looking and paying full attention. I don't want you to do this alongside in CAD. So this is what we're going to be doing. It's a, by 2 hours from now standards, very basic part. The process that we're going to follow is, and I'm going to transition for this, we are going to be going to create a sketch, and then we're going to do all of our lines, and all of our lines are going to be blue, and blue means they're going to be unconstrained. And then we are going to constrain them all with dimensions and, unsurprisingly, constraints. Now, I haven't shown you constraints yet. It's all right if you don't know it. We're going to get through it. So I'm going to follow the same process. I think you already know this part. You might have already done it. Actually, no, you haven't because your hands are on your head. But we're going to create a sketch. Let's see, I'm going to create it on this plane. And then I'm going to rough out this model. So I'm going to, I've clicked on line tool, and now I'm going to make a center line. Actually, no, I'm not. I'm going to do something that's going to be more dramatic. I'm going to just kind of just like trace around roughly what this looks like just by eye. I'm going to click and hold for this part so I can make kind of an arc. And then I'm going to click and hold. Sorry, I was just clicking normally. And I could keep going at this part. I could trace all the way around. But I am an engineer and I am incredibly lazy. So what am I actually going to do? No, I'm not going to trace it all the way around. I'm going to press escape and I'm going to use the mirror tool. So before I can use the mirror tool, I need to make a center line. And then I'm going to press X to make that a construction line. And now I've selected these 3 lines holding down shift. So I'll show you how I do that again. I hold down shift and then I click once, twice, 3 times. And now I can click mirror line, click on this and press OK. Cool. This is already sort of getting there. I have no clue what's happening here, but luckily with the Power of Fusion, I can just kind of click and drag it. And then, oh wait, no, it's not letting me snap. Okay, So how do I get these two lines to connect? Because I want this to be like, obviously in the drawing, it's one full line. How do I make that happen? It's this lovely menu that I haven't talked about yet, but I was alluding to. Constraints. These are really cool. I know it sounds really stupid, and I'm getting too excited about this because it's just like Fusion 360, but they're like, constraints are really cool. So you can press this one, coincident. Don't worry about all the other ones. They don't matter. And I can click on this, and I can click on this. Oops, actually, no, that worked in reverse because one of them was already selected. I'm going to press escape so nothing's selected. Then I'm going to click coincident. I'm going to click on this. And then I'm going to click on this. And whoa, what just happened? Everything broke is what just happened. Let's see if I drag this out though. Wow. So just to clarify what just occurred there, I'm only going to explain the coincident constraint, and then I'm hoping you can, in your own time, kind of learn the other ones. But like if I make two lines, and I select this one, and I select that one, I can then apply a constraint. Like I can make these 2 points coincident, meaning they're in the same place. And you see how Fusion just like does the work for me of lining them up. And like, there's other ways you can do it. So I can select this point, and I can select this point, and I can click horizontal/vertical, and it will make them horizontal. So there's some intricacy behind why it's like horizontal or vertical. You can look into that in your own time. It's just so you get the idea that these are really useful. Spend like 5 minutes just making some lines and seeing what happens when you apply different constraints to them. You can even see like really like bog standard ones that you use all the time. You'll make a circle and then you want something to be a tangent to it, so it's a smooth line. Well, then I can press, oh, what's this? Tangent. Wow, didn't see that coming. It makes it a tangent. And you can see how like if I extend this, it's just like Year 9 maths meant it to be. It's beautiful. Okay, I got very distracted there. Back to making this. So I'm still like doing it all with blue lines, and then we can do one final line along the bottom here. And cool, it's now turned blue, which means that it's closed, and that's what we want. And just like reiterate, if your like object isn't, not object, if your like sketch isn't closed, then you can probably just need to use a constraint somewhere, and then that will close it. So I'm going to add some more details here. I'm going to line across there. And then, where is it? I'm just going to like pop a line across there. Oh, that's kind of askew. How do I fix that? With a constraint. Wow. No surprises there. And then I need to put a circle in here somewhere. So I'm going to put it like roughly like that. But this isn't accurate. This isn't like an engineering thing yet. It's all kind of wishy-washy. And my one is very obviously different to the one that I have on screen. So what we're going to do now is we're going to start applying those constraints that we were talking about. Mainly, we're going to be applying dimensions. Now, the first one that I'm going to do, just because I want to be kind of like clean and responsible with my CADing, is I'm going to fix this to the origin. So I've selected that bottom line. I'm going to make it coincident with this point here, which is the origin. And you see that? Oh, wow. That line has turned white. What does that mean? I have no idea. No, so white actually means that it is fixed. There's 3 different types of fixed. You have like blue, which is completely unfixed. Then you have white, which means it's like fixed in one direction. Because of constraints, but you can still like extend it. Or you have like fixed. I know, yeah, very technical, which is using the fix tool and then it turns green. And then it's not going to move no matter what you do. Like it'll still move like that, but I can like select this and it's not going to move. Now I'm going to press dimension. Actually, no, I'm not. Psych. I'm going to make this circle a tangent with this inner part. And then I'm going to make it a tangent with this part. And then I can just kind of, actually, no, I don't think I'll need to do it with the other side because I've already mirrored this. So I can be smart and actually, no, I'm not going to be smart. I think it's easier to explain if I just make it a tangent with everything. Sorry, I'm feeling a bit lazy. Cool. Look at that. This is getting better. It's looking more formal now. But there's still some extra stuff we need to do. So I'm going to press D to dimension. You can see it's also up here, but I want you using the shortcuts. And I can select these 2 points along here and put a dimension in. Enter. Now, if I go over to my presentation, and see how it has 180 there. Now, what is that? Is that 180 centimeters or 180 meters? No, it's millimeters. In engineering, every single dimension, unless, like, especially in like these sort of engineering drawings, unless it's said otherwise, it will be in millimeters. If it's a very nicely done drawing, they might even have a box in the corner that actually says that. So we're going to go back to our Fusion 360, and I'm going to set this from 20 millimeters to 180. Whoa! That doesn't look at all like our model. And so you're going to see that as we put these dimensions in, everything is going to turn white, and it's also going to look just like what we have on the screen. So let's press D again, and I'm going to, let's see, I'm going to constrain this top part first. So I'm going to press D, click this line, and then this line, and then I'm going to do 45. Wow, that got really messed up. So I'm going to try and fix it. Actually, no, I'm not going to try and fix it. I'm just going to keep adding dimensions and see if it fixes it. And now with this line to this line, that is going to be 60. Wait a minute. Things are actually starting to kind of get places. What happens if I drag this? Oh, that looks promising. So I can you can click and drag, unsurprisingly. Now we're getting pretty close to having this look like our thing on paper. Now I'm going to add one more dimension here and here. And if you have a look over, you can see it's 75. So I'm going to set it to 75. And our tangents have disappeared again. So I'm going to drag them out. And so you can see how pretty much all the lines here are white now. There's only 2 blue lines, and that's the radii at the top. Now they're blue because they're unconstrained. So I'm going to press D, and then I can dimension them to, let's see, what does it have in the drawing? 25. So I can put 20, 25. And now we have a fully white drawing. So what you'll notice is this engineering drawing and any engineering drawing you get should have exactly the number of dimensions you need to get a white, fully constrained drawing in Fusion. Now, when you're making CAD models, you don't always need to have everything white. It's best practice, but sometimes you're just tweaking things and you don't want it to be fully constrained. Sometimes you just need to drag things. It's all right if it's not white. I just need you to know what a white line is. And with that, we're done with this first little basic sketch. So as you might have heard me mention a few times by this point, I've been using keyboard shortcuts during this design process. Keyboard shortcuts are such an easy way to pretend like you know what you're doing. And it's that sort of mentality where if you pretend you know what you're doing, after long enough, you will actually maybe know what you're doing. At least it's worked out for me so far. So I can highly recommend learn the keyboard shortcuts as you go. I do have to be honest though. I only knew about half of these before I was preparing these slides, and I've still been able to do all the stuff you saw me do previously. So the main ones are definitely like dimension and normal line. Whatever you can do to speed up your workflow. So here comes the trial by fire, ready to ruin all of our days. Now I would like to preface, originally I planned for this to take 10 minutes when I was teaching in person. In reality, it actually took about 50 minutes. And that was even with, so like what I ended up doing is I did 5 minutes of timer, got all of the students panicking because they were like kind of like half paying attention when I was doing this practice sketch over here, this one. And then after 5 minutes, I saw which students had made the most progress, and I got them to help out the students which had made the least progress. And so I was able to use that to kind of bridge the skill gap. If you're just sitting on front of a screen, or you only have like one person next to you, obviously you don't have the benefit of having a skilled student over your shoulder. So I'm going to need you to, without any hesitation, ask questions in whichever, like whether it's a Discord chat or an Element chat, or whether it's like, I don't know, Gemma 3 and you can give it images and it'll give you answers. Actually, no, probably don't do that. I don't know how well it'll handle CAD. But my recommendation, ask questions as you work through this. The other thing I need to highlight before I get into showing you how to make this is this dimension here. Some students couldn't see that there's actually a center line along this. The reason why you don't need the dimension for the width of this is because of that being symmetrical. I think that should be all of the info you need. Now, I'm going to show you how to make this, though I highly recommend that you try and do it yourself, because it's just a better use of your time learning if you do it yourself than me just talking at you. It's also just more fun. I don't know, play some music in the background so you don't need to deal with me. And then you can skip to once you're done with this part, or like just like check in every now and then if you're struggling. Without further ado, I'm going to actually do things. So let's close this model. We don't care about it. No, don't save. This one, no, don't save. Oh no, it's going to open that really, really large model. So I'm going to press new. Cool. So we're going to go into that folder that we made originally. I have a suspicion this isn't, oh no, it's in here. CAD workshop folder. Fusion is thinking. So we are going to be making this sketch. So let's do create sketch. And then, what is it? This looks, I think if we look at the original assembly, it was like flat. So I'm going to make it on that plane. And then let's box it out. So I'm just going to kind of rough it. I'm going to do one line along the bottom. And then I'm going to dimension that line so that all my other stuff is accurate and I don't end up with really weird numbers. If you remember, like when I was doing that example model 2 minutes ago, how once I started dimensioning it, everything looked really weird. If you dimension your first line and then do everything relative to that, you won't run into that weirdness issue. So that's what I'm going to do now. What is it? 154. 154. Easy. Okay, so now I can do everything relative to this, and I'm just gonna kind of copy it by eye. So let's do line over here, line down there, line down here. You'll notice how Fusion is applying constraints automatically as I'm drawing out these lines. Like this line is actually already white, even though I haven't manually constrained it at all or put any dimensions on it. That's because Fusion has assumed that it is perpendicular. That's what this tiny little icon, barely visible, means. That's from this one. So I'm going to select these 2 points. I've held down Shift to select that, and then I'm going to do coincident. Look at that, we already have our closed shape. So the way that we're going to break this down is that we are going to just plop down the basic shapes. If I look at this drawing up here, I can see how there's 2 circles, then another 2 circles, and then 2 rectangles. And that's all. I'm just going to plop those into my drawing first, and then I can constrain them and see how they like work together. I'm currently me from the future compared to me from 2 minutes ago. And that's because I tried to go another route and it doesn't work with the way that I've dimensioned this drawing. Sorry if you were trying to go that way while you were working on it. So let's follow that plan that we just came up with. I'm going to make 1 circle there. I'm going to make another circle with like clicking over this center point. So it already has the coincident constraint. You can see that little circle there. And then I'm going to do the same thing again. Nice. And then what do we need? 2 rectangles, right? So let's make 1 rectangle. I think it's like kind of a long one. And then we need another rectangle that's kind of like a smaller one. Our lines on here look different to the lines on that drawing though. You can see how the lines in that drawing are like dashed. So the way that we do that is we use the X hotkey to turn them into construction lines. You'll notice there's also line type over here. That's another setting that you can use. And then same with like all of this. I think these are all meant to be construction lines. I'm selecting each of those. Now, this is the part where we start constraining things. Actually, just before then, I'm going to put the text in. So I need to make my text box, and then I can just go add the cool. First things first, I think the easiest place to start is to put the dimensions on the circles. That looks like something that's not dependent on anything else. So I can start there. So let's use D for dimension. D, click on this, and then that is 10. And then I can click on this, and that is 35. Same thing here. This one is 20. And this one is 70. I'm kind of running out of space here, so I'm going to dimension this side as well, because I can see that it's kind of different to my drawing. This is 110 on the drawing. And then I can drag this out so I have more room to work with. Okay, so these are getting kind of set up. I can see in my drawing that there's a little tangent symbol. So if I look here and see just there, there's a tangent symbol. So I'm going to make these 2. I'm going to hold Shift, select these 2, and tangent. There we go. And funnily enough, I can see a tangent symbol down at the bottom, just here as well. So let's apply that as well. Click there, and I don't even need to hold Shift. If I'm already in tangent mode, I can just click one, click the other, bang, tangent. I can also, I notice on that drawing that this line and this line look like they're overlapping. So I'm going to add that in too. In this case, I'm going to use collinear. So, you know, like really working on that year 8 maths, all the proofs that you did comes in handy for CAD. What can we do next? Kind of an open question. So we're going to look at what dimensions are independent from anything else. Fortunately, the person who designed this has decided to put everything dimensioned to the same datum. What I mean by that is that all of these dimensions here are referencing this one line. So and then it's kind of same thing happening for these. All of these are referencing this one line. I'm hoping my cursor was visible on the screen there, otherwise you might need to look really closely. Basically, look at my big arm up in there. All of the dimensions down here reference this line. All the dimensions over here reference this line. There we go. So because they all reference the same line, we can use them really quickly. So I can see it's 31 to here. 31. And then I can see that it's 53 to here. That's very interesting. I can't put a dimension to like anything there. Nothing's really working, is it? So what I'm going to do in this case is I'm going to create a point. So Fusion kind of knows if there's a place of interest, and I can put a point there. Now in theory, yeah, you can see how it like snaps once I've zoomed in there. So I'm going to click once it's snapped, and that's created a point where it's a tangent. And so I'm going to dimension, click on that point. You can see how there's like different like angles that Fusion will let you do dimensions on. And we're going to do 53. Never mind, that didn't constrain the way I wanted it. I'm going to make that coincident with that as well. And what can we do next? I see that there is an 88 that goes all the way up to here. So just to clarify, I know I had a student who got confused. They thought it was a tangent to that area there. No, this 88 is dimensioning up to that point. Oops, I was clicking in OBS. All right, so yeah, dimension. And what else do we have? A 102 to the center of the circle. So that's nice. We're making some progress. Now I'm going to do the dimensions on the other side. So I know from here to here is 3.5. So that's going to be 3.5. And then from this line to here is 9. Oh yeah, that's starting to look like the drawing. And then from here to here, they didn't do a datum for some reason. Probably because it's a like relative part on the rack and pinion. And wow, look at that. All of our lines have suddenly turned white. That's a really good sign. In fact, there's only one line that isn't white, and it's this one. These two are orange. We don't actually care about these. I'm not going to bother explaining why. You can ask your lab demo. So what we want to do is we want to figure out this. Now, if you recall, that note I gave at the beginning, there's actually a center line through here. So I'm going to add in that center line. Just like with this point, I can make it in any direction I want. I'm going to press X. Actually, no, I don't need to worry about that. I'm going to do it a different way. Because it's symmetrical, we know that the distance from here to here is the same as the distance from here to here. In other words, this distance is going to be, and this is a really fun trick that a lot of people don't know. At least I've run into some students that don't know it. And it's that you can do your maths in here. So I can do 53 minus 31 times 2. And there we go. And then we can put this to what? Emu Robotics. Emu Robotics. And we can put a funny font on it. congrats, you've done the sketch stage. Obviously, this doesn't work out because we're on a call. I mean, a video, yes. Bodies. What are bodies? I'm not talking about human bodies. I'm talking about computer bodies in Fusion 360. And you can see a nice little render up there in the corner. So bodies, if you recall from that like 5-stage process that we were looking at the beginning, that's the second stage. And if you remember from right at the beginning when we were messing around, bodies are what we make after we use extrude or any of these other different kind of buttons here. I'll let you take a guess at what they're called. I actually didn't remember all of them off the top of my head. It was kind of funny. I had a student clear me up because I thought a rib was called a web because I mean, technically in some cases they are. Yeah, I'm going to move on from that before I get too flustered. So yeah, so we have our sketch. And then we need to turn into that. How do we do this? No surprises. We are going to use extrude. So what information do we need? There you go. That's all the information you need. And here's a 2-minute timer. I'm sure you can do this. Or if you can't, I'm going to keep working. E to extrude. And then you hide the body. Hold down shift. Make bodies visible again. E to extrude. Hide the body. Have the body come back. And 20. And there's an extra thing we can do. So we can hide the body again. And select that text. And then we can select an offset. Make it at surface. Where is it? I want to start at there. And then I'm going to drag it in. And there we go, time is up. Now, as you might be familiar, weight is very essential. Like having a light robot is pretty important if you want to have a fast robot, or even more importantly, a robot that doesn't tip over. So I've done some finite element analysis on this model, and just for some background, the most important thing here isn't that any of the numbers are right. I made them all up. It's just that it looks right. So we're going to roll with it. And here's our original model, so you can kind of see like those overlaid. Now, in case you don't actually know what this means, red means it's under high stress. And then where it's not red, what does that mean? It means it's got no stress. So really, we only want to keep material where there's stress, or otherwise we're just carrying it around for no good reason. So what we can do is we can remove material where there's no stress. Now, there are proper ways to do this. If you want to do it the proper way, you can watch a separate video. You can just look up FEA shape optimization, Fusion 360, and then you will be able to learn much more than I can teach you in this short video, because this is probably your first time using Fusion 360 and you don't need to worry about that for now. So let's go into our workspace and figure out how to take chunks out of this model. So the optimal way to do it is using the same sketch you originally made, but that can get messy. Like I could add a circle here. And then in my original extrude, I can just click out that circle. And you'll see I now have a hole. But that can get messy if we're doing a lot of intricate geometry. So what I prefer you do is you do all your weight saving in a separate sketch. And we don't want to do the sketch on a face of the body because then it's dependent. We're going to do that sketch on the original plane. And now I can make this visible. And what I'm going to do, in this case, I'm going to make it look a bit more fancy. If you're just doing this in your own time, you can do it however you'd like. You can just do it with circles. Generally, bigger circles are preferred. Actually, no, that's a little bit too general. The reason why I'd say that is because stress is generally around the outside of parts. It's not really in the interior. So if you're doing lots of small circles, like hundreds of small circles, it's not going to be as efficient than if you had a big circle and your part was just highly stressed around the border. Either way, we're not going to do that at all. We're going to be making some triangles and using the extra tools in here, such as rectangular pattern. And then I'm going to click and hold to make a circle. Okay, it doesn't want to be nice into a pattern. That's all right. Actually, I'm going to do this a different way. I'm going to Control Z a couple times. I'm going to hide this body. Okay, let's make a triangle. So if we're doing weight saving holes, we always use equilateral triangles. How can we make it equilateral? Well, we can make all of the sides equal. And then what do we want to do? Well, we can fillet all of these corners so that they're round. Now this is quite a small circle. I do want to check. Oh, a very small circle. Okay, so let's make this a little bit bigger. Something like that. And now we can fillet all of these corners. Actually, I'm going to press... Does it let me? Okay, no, it doesn't. So I'm going to just press enter. And I'm going to double click this. I'm going to set it to the same as that. And I'm going to do the same thing here. I'm just going to press enter. And I can double click this, click on that dimension, and it lets me use that dimension. Oh, my stuff is broken. I'm going to click these again and press equal. And there we go, fix itself. Is this actually, yeah, I think it should be working. All right. So what I can do now is create a rectangular pattern upwards. And then I'm going to just put a random line. So what I want to do is I want a mirrored copy of this. I'm going to get a random line, press X, and then I'm going to mirror it about this line. Now, so that has a whole bunch of constraints. You can see all those mirror constraints floating around. I want to get rid of those. So I'm going to Control C, Control V, And now it'll give me a brand new copy that doesn't have those constraints. Actually, pretend I did this without all of these extra copies, because really I just want a single triangle. And I'm going to reconstrain all this. Whoa, that gets angry. All right, so let's make this and this tangent. Yeah, that brokey. This is getting all kinds of messed up. I've done this in a really dumb way. But it seems to be working. There we go. And then I'm just going to dimension the distance between these. Oh no, I'll make it like 5. Neat. And so now I can select both of these and do a rectangular pattern. Actually, wait, I'm going to situate these in a corner of the model first. I'm going to like move it over, just dragging it. I'm going to press, I'm going to click on this line. Actually, no, I'm going to save that for later. Well, it won't let me click on this line. So I'm going to click on this line first. Then I'm going to hold down shift and click on this line. And I'm going to press D. There we go. Now it lets me select both of them. I'm going to set that to the same as this distance. And what is it? I think we're going to want this to be mirrored before we do anything else. I'm going to hide this because it's making it hard to see. And then I'm going to put a little construction line. X. Dimension. I'm going to make this distance divided by 2. And then I'm going to select everything here. And I'm going to mirror it across that construction line. And now you'll see that I have a pattern that will tessellate really nicely. In this case, let's set it to 38. Or 43 looks about right. And for this application, I think about right works. And I think I need to increase this slightly. There we go, good enough. Nice. So now we have this tessellating pattern across everything. Let's see, how does it line up? Doesn't line up very nicely. So what I'm going to do, I'm curious if it'll let me drag or if it's going to lag out on my computer. Oh, it's thinking. Yeah, so I'm going to, oh, it did work. Very nice. Oh, it's still selected. Okay, yeah, it's like really lagging out. Oh dear. Yeah, so I'm going to drag this over to here. Click again, so let's go of it, escape. And I'm going to dimension. Actually, no, I'm going to click on this line, dimension. And I'm going to set that to the same as, what do we have over here? 5, enter. And now it's going to take a sec to think. And it's resized everything for me. And now I can edit this rectangular pattern. Where is the rectangular pattern constraint? It's hiding. There we go. There it is. So I've double clicked on that to edit it. And now I think I'm going to increase this to 4. Oh, that's the wrong axis. Wait, what? I'm getting a little confused. I think this is just because of lagging and it's tripping me out. There, okay, yeah, there we go. And oh yeah, that's why. It's because I'm using spacing and not extent. Um, hmm. I need a second to think. Okay, so what I've decided is that this dimension here is messing everything up and making it hard to fudge this the way that I wanted. So let's cancel and then delete this. And I'm going to swap, actually no, I'm not going to mess with that for now. I'm going to go back into here. And now I'm going to edit this rectangular pattern. And we're going to set this to extent. And then I'm going to increase the quantity to 4. Sorry that I just hit the microphone. And now you can see that lines up quite nicely. And then I believe I actually can get away with dimensioning this outer line. So I'm going to press escape. And then I'm going to, let's hide this body. And I'm going to select this and then D, enter. It's going to think really hard. Yep, you're happy with it? Cool. And then everything else seems to roughly line up. I'm going to decrease this to 4 and see if Fusion explodes. Can it do the maths? Did it update already? Oh, must have. Huh. I'm kind of impressed. And now I need to edit that rectangular pattern so that this is tessellating properly in that direction. And now what do I want to do? I'm going to extrude all of this into my canvas. Oh no, there's one thing that I forgot to do on my original sketch. Oops. Yeah, so we're going to drag this down. Fusion's going to take a second to think about it. Oh. Oh, maybe it's going to take a really long time. Okay, no, cool. It came back to us. Oh. Yeah, I'm going to use the move tool instead. I'm getting kind of antsy by how laggy this is. Fusion, yeah, okay, there we go. Fusion is finished thinking. I can press, oh yeah, okay, cool. And now I can dimension these. And I can set this distance. Enter. Now I can double click it. And I can set it to the distance that we have down here. So everything is the same. Nice. So what we're going to do with this sketch is we are now going to remove material everywhere we think we can get away with it. So I'm going to select everything to begin with. And then I'm going to bring the bodies back. And then where should we get rid of it? Now, so if we go back to this. Okay. So we want to keep our material around all of here. Let's see, is that a good guess for the moment? Obviously, we don't want to get rid of these ones. Because they're like right on the edge. And then, all right, yeah, how does that line up? I reckon we might, yeah, we're going to want to get rid of this one as well. How does that look now? That's looking pretty good. And so we're going to type in 6. And Fusion is smart and it knows it knows where we want to cut holes. And there we go. Now you can see we've taken out some of our text there. So what we can do is go into our sketch and just add a line across the top there. So we know sketch is there. And then I reckon we just add a flat line along there. And then we can go into our extrusion. And we can just get rid of those bits so that we don't cut them. Now, we are almost finished with this. There's just some last things we need to do before I would be happy with it. And that is adding some, where is it? Adding some fillets and some drafts just to clean everything up. So we're going to go back to here. Also, I think that text is a little bit low, so I'm just going to make that look a bit nicer. Let's make it centered, move it up to there. And then what we can mess with the spacing. This is overkill, by the way. I'm just being a little OCD. Now, so we can press F on our keyboard to open fillet. And then we can go in here and, oh, that's the wrong line. We just want to select these vertical lines. Specifically, we're selecting the lines where there are sharp corners. Now, a sharp corner like this one, not going to be the end of your robot. But a sharp corner like this, like a 90-degree sharp corner, or even like sharper than that, like say like you had a 30-degree one, like that was like really like tight like this, that is going to be a stress raiser. And we do not want stress raisers on our robot. Because if any part of this made up assembly is going to fail, it's going to be that place where we had that sharp corner. You can kind of picture, if we go back to the overlay, all of this red area, you can picture anywhere you have a sharp point on your CAD model. So like these little areas here, those will be red areas. And we don't want red. Red bad. So I'm going to add, let's say, 2 mil fillet. Actually, no, maybe I'll do more than that. 3. Yeah, I think 3 is good. And cool. So there are some other fillets we might want to add, like this would be a little bit sharp. Obviously, if we're CNC machining something, we need to be very careful with the fillet tool because it can be very expensive very fast. But otherwise, if we're just 3D printing, don't need to care about it. Fillets everywhere. Fillets fun, fillets are happy, fillets friendly. Everybody loves fillets. And so I'm going to add just some extra ones on here. Let's add, what I reckon I can just use the same dimension. So if we want to add new fillets to something that's already filleted, you can see how it won't let me select anything new. Like it won't let me select an edge. So what I need to do if I want to select new ones is I need to put 0 into that fillet, and then it will let me add new ones to it again. Oops, I pressed enter. I still want to be adding stuff. So now I'm just going to go around the outside of the model. And yeah, it's looking pretty good. And there's one other part that's bothering me. And it's this. It looks it's kind of sticking out quite aggressively. So to make that look a little bit neater, I am going to add a draft. Now it's in the modify tab. We haven't used that yet. You can have a look around in here. For now, you don't really need to worry too much about it. Am I even doing this in the right order? I hope so. No, I'm not. So I need to select this face first. I believe, yeah, I'll just make it 30. And then what is it? I can't have this draft extend out or it's going to go over there. So I'm going to choose that as my face for it to be relative to. And I'm going to move my fillets after that in my timeline. I will touch on the timeline as soon as we get to part 3. I just haven't got to that bit yet. I'm going to get you to pretend there wasn't an awkward jump cut there. Now it is time to say goodbye to bodies and hello to components. Fortunately, it is really quite easy to turn a body into a body into a component, as you will soon see. Something I should clarify before I go into this, though, just so you know about it in case you see it, is that there are different ways of going about making components. And this depends on whether you do your assembly in a single file or a multi-file Now, what I'm going to be teaching you today, or tonight, or whatever time, is multi-file. Here are all the reasons why we do this. If you want more reasons, you can ask your chatbot, because it's also probably 2030 when you're watching this. Now, the first component we're doing is really easy. All we need to do to turn this into a component is, I've clicked back into this window. I'm going to press Control S. And then I'm going to name this. Now, what do we think this should be called? I'll give you some hints. It was on the slide just then. It's the kind of like the backbone that's holding everything, and it looks like a plate. It is the back plate. So I'm just going to call it that. Back plate. And enter. And you'll see once Fusion is done thinking and uploading that it will show up in our folder up there on the left. So this still isn't a component yet. What we need to do to make it a component is we're going to make a new design. Actually, I'm going to close that. I'm going to go to here and I'm going to hide this. So you can see up in this corner, new square. I'm going to click on this square to open a new file. And I'm not going to do anything in here. I'm just going to press Control S. I'm going to call this. Usually you just put it like something assembly. In this case, I'm just going to do nothing assembly because I'm out of ideas. And we'll wait a couple seconds. Fusion's going to upload and sync. You know, we see upload progress, and then nothing assembly appears. And all we need to do now to turn backplate into a component is we click and we drag. And nice, we have our first component in our assembly. And now, because I haven't covered joints yet, there's a next step that I'll leave for that. And we're going to press Control S, save our assembly, and then we can close it. We don't care about it for now. We're going to make the rest of our components. Years. Now this looks scary, doesn't it? There's a lot of like detail there. We already struggled enough making just like this thing. How are we going to make this? Well, it's actually like really quite easy because Fusion does it all for you. So if we go into utilities, we don't even need to like make a sketch or anything. Like, so normally like sketches in solids, we don't need to make a sketch or anything. We just go utilities, add-ins. Wait a second for the menu to come up. It's thinking. There we go. And then we scroll down to spur gear and we press run. And now we've got these numbers that have come up on the side here. So we've got our pressure angle, our module, number of teeth. I'll be frank, my first time learning how to use this properly, like a month ago, the way that I learned it is I just put in random numbers and made random different gears. To make this one specifically, the main thing that we care about, actually no, I'm gonna go through the design process based off our backplate. So we're gonna open our sketch here. And let's make a gear. So the one thing that I definitely know is that our hole diameter needs to be 20 and that it needs to be like roughly 770 in diameter. What this diameter actually is our pitch diameter. It won't make sense for now. You're just gonna have to mess around and then you'll be able to understand what the pitch diameter is, or Google it and that will make a lot of sense. So I'm gonna go back here. Going to run spur gear. And then I can, let's see, I'm going to make the module. Actually, let's see. So currently the pitch diameter is 304 mil. And the only info that you really need to care about right now is that we need the pitch diameter to be 70 mil. What can we do? What numbers can we mess around with to make that number go down? Well, let's see. If I make this 20. Oh, that's not a number. I just put in gibberish. We put in 20. Oh, okay. So pitch diameter goes up a lot. So what if we make it small? What if we make it like 10? Well, it goes down. What if we make it like 5? Goes down. What if we make like 1? It's giving us a warning. So I'm going to leave it at 5. But like, it's still not small enough. Because we need to get pitch diameter down to 70. And it's 120. Anyway, I'll make a gear like this anyway so you can see what it looks like. So yeah, that doesn't look anything like the gear that we're trying to make. I'm not sure what's going on there. So let's have another go. I'm doing Control Z to get rid of it. Let's go back in. Add-ins. Spur gear. Oh, it's syncing. And then so we know we want our module to be 5. And then the number of teeth. I don't know, I'm just going to keep decreasing that until it fits. Actually, wait a minute. Something seems kind of suspicious here. It's almost like the module times the number of teeth is the pitch diameter. And let's see, like what? If we put like 7 as the module and we put 10 teeth, would you look at that? It's a pitch diameter of 70. So let's make this gear. And what is it? I think we need the whole diameter to be 20. So I'll put that correctly. And there we go. What a funny looking gear. But that does look different to the one that we want. Now, why would that be? Well, it's a pretty dumb question because we have 10 teeth on here and 14 teeth on this one. So no surprises there that it looks different. The real main thing that matters if you want 2 gears to mesh is that they need the same module. Other than that, you can just like change the center distances and it'll work. The biggest thing is as long as the module's the same, it'll work. So in this case, I'm going to stop fluffing around. I'll just do it properly. And so no surprises. I'm sure you're all experts on it now. We can go add-ins, spur gear, module 5, number of teeth 14, and hole diameter of 20. And just like that, something which seemed so scary and daunting is super easy because we've done it like 3 times and now it all makes sense. And so we're going to press Control S. Oh, I'm clicking on the wrong window. I'm going to press Control S. And we're going to give it a name that actually makes sense. So I could call it gear. But what happens if I have more than one gear? Then I'm not going to have any idea which gear is which. Or I could call it gear 1 and gear 2 and gear 3. But that is not that helpful. Because what if I have like different size gears and I'm trying to find a gear based off my sketch? Well, if we look back at our sketch, what's the main difference between these 2 gears? We know the module's the same. We know the number of teeth will be different, and we know the pitch diameters will be different. So we can like name it based off either of those. The main one I'm going to use is just the pitch diameter. Because generally that's what's actually stored in the sketch. I don't have the number of teeth in the sketch. So I can look at the sketch, I can see the pitch diameter is this, and then I can look through my files. So let's call it 70 millimeter pitch diameter gear. Enter. Let Fusion think for a second. And then we have it in our files. And all we need to do to convert it into a component is to open up our assembly again. So I've just double clicked on that. Waiting a sec for Fusion. So let's convert our gear into a component and I can just drag it in. And would you look at that? It's showed up as a little component. and we can just press OK. Now, this one looks a little funky. It's like we've got a gear and then we've got something on top. How are we going to do that? We're going to switch back to Fusion. We don't need to worry about this assembly file. We're going to make a new file, and then we're going to make a new gear. Unsurprisingly, I think that's the easiest place to start, right? So we're going to go spur gear. Module. We know the module needs to be the same as the other gear we made, so that's going to be 5. Number of teeth doesn't really matter, other than the fact that we need to get to a pitch diameter of 35. When we go back to our backplate, we know the pitch diameter of this needs to be 35. So let's go add-ins. Spur gear. And we're going to have a module of 5, and then we're going to change our number of teeth until we get to a pitch diameter of 35. Or, as you'll find if you do engineering in uni, you can use maths, in this case very basic maths, to find it first try without trial and error. And then our hole diameter is 10. Neat. What a cute little gear. So what we can do now to add the kind of knob thing that we have is we're going to do a sketch. Now the first thing we're going to do is we're going to make a sketch in one plane on this face. And I'm going to, let's see, I'm going to create an arc, center point arc. And I'm going to go, yeah, until it's tangent with this. Let's go around. I'm going to delete that midpoint, but I am going to make it tangent. And then that will let me drag this around. And then I can make a straight line. I want to make sure that's horizontal. And then I'm going to make these two coincident and tangential. So they meet nicely. And there, now you can see that's fully constrained as well. And now what else do I want? I believe we look, you can see how it kind of goes off the edge on that side. So we can model that. And we're going to have, I reckon, yeah, we have like a arc of the same diameter. So in this case, I think I can actually do this with a slot. So I'm going to do that instead because I think that would be easier. So I'm going to press Ctrl Z a few times. And then I'm going to go slot, center to center slot. And then I'm going to increase the radius. And it doesn't need to be constrained yet, so I can add my constraints afterwards. I'm going to select these two. I'm going to make them tangent. And then I'm going to select this and this, and I'm going to make these two tangent, I reckon. Nice. And then the only other thing I'm going to do, and I was going to touch on this later, I'm going to use a trick called project. So I press P on my keyboard and select this line, and then I can bring it into my sketch from the body. Now I can press E. So I'm going to open up the sketch and press E. Actually, no, I'm just going to do this. So yeah, I'll probably leave that out. And then I'm guessing it's like 6 mil or something. Doesn't really matter too much. So there we go. This neat looking thing. Now, did this use, no, this made it a new body. I want it to join. I want this all to be the same body. Now you can see, so now that line is like going clean through them. Whereas before you can see how there's like a divide there. And now what do I want to do? I want to add the little kind of like handle for your hand for you to hold. So you can like spin this. So I'm going to use something which you probably haven't seen before, or maybe haven't seen before, revolve. Now to use revolve, I need my sketch to be on a different plane. So I can see, I'm going to make my origin visible. And then I'm going to make a sketch on this plane. Now, why am I going to do that? That's because I can tell that this sketch will go through the center of this circle. And that'll allow me to make it just over there. Oops, I didn't mean to finish sketch. So yeah, so we're in here. And now we can, I'm going to select this. I'm going to press P. I'm also going to select this, enter. So now I have like this point in this line to work with. So I can go up here. Not too tall, just like a decent amount. And then I'm going to use a Bezier curve to make something smooth and comfortable looking. And then I'm going to have it meet a straight line at the bottom. And so what you should see here, you can click on the Bezier curve and it has this little green line show up, and that lets you kind of control it. Now I could be really corny right now and say it's like using the force or something. But I don't know, it's a bit more simple than that, not that advanced. And neat. So now we have this little like region here. We have another blue area, but it's in a different plane to all of our other stuff. We haven't really worked in 3D yet. We've just been going like 2D and then extruding. So what we can do is we can do revolve of this area, and then it wants to select an axis, and we can use a line as an axis. So I'm selecting this line here, and then look at that. We have this little handle that we can use. Now, so I am noticing that it's clashing with that. So I'm going to scooch this line over just a little bit to make it smaller. There we go. And now we can save this. Sorry for another jump cut. My mic cut out and I just lost like half an hour of work. Yeah, so we're going to go save as, and then we need to think about a name for this gear. We already know from our last one that we want to do pitch diameter. So what's the pitch diameter of this gear? Actually, yeah, as you can probably already see, it's filled in 35 millimeter pitch diameter. And cool, we save that. You can see it's already saved. And this thing, which should have left, is still there, even though, there we go, cool. Fusion is cooperating, barely. Okay, so we finished this, and now all we need to do is drag it into the assembly, and we can turn it into a component. So we can click it, hold it, drag it. One reboot later. Okay, yeah, so there's no surprises. You click this, you drag it in, and then you have a new component in your model. So on to the final component. As I'm sure you might have realized, there are only 4 components in the original model. We are slowly but surely getting there. Now, how do we make a rack? Because you might notice it does look quite different to a gear. It's not a circle. Now, there are different ways you could go around it. Like maybe you could just make some spiky thing and you could have like a zigzag that you just make out of lines. That's not going to mesh nicely. It won't look proper. So what we're going to do, if you give me 8 years for this to open, is that we're going to use a secret gear. That's right. It's all involute gear generator. It always was and always will be. So let's make this from scratch. Do we start with a sketch? No, we don't. We're going to go straight into our utilities, add-ins, and then spur gear, run spur gear. So what module do we need? Everything else is module 5, so it has to be module 5. How about our number of teeth? Think really hard? It actually doesn't matter at all. Because in this case, the only reason we change the number of teeth is to change our pitch diameter. And we also don't care about the pitch diameter. So what we're going to do is actually go for a really big number, like, I don't know, 60 or 80. Now that's going to leave us with this chonker of a gear. So which part of this gear do we care about? I'm pretty sure you can already figure this out. We only care about having one of these profiles. So what we could do is we can make a sketch, and we can just like make a sketch on the face of this gear. But I'm not going to do that, because if I did do that, it would lag out my PC. Now your PC probably isn't as bad as this virtual machine, but the important thing to know is that if you make a sketch on a face that already has a lot of detail, i.e. this face that already has a lot of lines and detail, then every single time you add a line on that face, I'm pretty sure Fusion has to think about the outline of that face. Like it has to calculate every single other line just for your single line that you made in that sketch. So what we're going to do is we're not going to use this, and we're going to use the origin. And we're just going to make a flat sketch there, and then we can bring back our spur gear. For some reason, we're upside down. I'm not sure why that happened. So let's turn around the right way. And now we are, what? Are we going to trace around this with our line tool and try and get something really accurate? No, because there's like really nice looking curves here. And it's also going to take a lot of lines to try and replicate that. It's almost like, what if Fusion had a way to trace details for us? I've actually used it already during this tutorial, and it is the miraculous P button. Yep, that's right, project. Now, what do we want to project? We could just project the whole gear, click, enter, and oh, it's thinking. It's thinking quite a lot. And then what? I can hide this, and oh wow, that's a lot of stuff to have in a sketch. That's kind of messy, honestly. How much of this do we really need? Well, if I think about it, none of these are useful to me because they're all off axis, and I want to make a rack. Like we're trying to make this long toothbrush thing where they're all in the same line. So what we're going to do is that we're only going to care about this one. So I'm going to Control Z, and then I'm going to project again, but I'm going to use the purple square mode, and I'm just going to click on the lines that I care about. I'm going to press enter. And there we go, much cleaner. So if we want to make our rack out of this, it's starting to seem pretty accessible, but like what are we going to actually do? We need like 10 of these. When we look back here for a second. Oh, and it's good to see my other camera has also died. Give me a sec. And it's back. So the first option that one of my students shouted out to me while I was teaching this was copy paste. And I mean, it's a decent effort, but as soon as you try and do it in practice, what? Copy paste, drag. I have to drag it the right amount. It's like really finicky because it's quite small. So I need to like what? Increase this bit by bit. There we go. Close enough. Enter. And then paste. And then keep going. As you can see, it's very repetitive. Road to insanity. Probably a bad idea. And it's almost like it'll be really great if there was a way in Fusion for you to do this, to make like large patterns. Well, generally with Fusion, if it would be great for something to exist, it already exists. You just need to like peel back the layers and you'll find it. So in the case, what you're looking for is the rectangular pattern tool. And then we can drag this out And wow, wowzers, would you look at that? And then we can put 10 in our quantity. I'm going to change this to spacing. Then we can just drag them out. And what? Line it up roughly. When you look out, when you scroll out, that's starting to look like a lot like a rack. So we can zoom in here. And then the way that I do it, this isn't the formal way you should probably do it, but I just fudge it. I kind of get the numbers close enough, and I press enter. And there we go. So if we switch back to here, we can see there's a little bit of a doodad on the end of the rack down the bottom. So we'll add in that. And that's just going to be like, I don't know, a line out here. And then we go have a line down. And then we go out this way. Oh, I'm missing an extra one. So we go up here. Then we control, select these two, coincident. And just like that. Now, my demonstration has actually backfired a little bit because my plan was for this to, where is it? Look like this. And then you'd be like, oh no, nothing lines up. That's tragic. And I'm going to need you to pretend for this part. And so what we need to do in this case is that we're going to delete this, and we're going to have a line that goes between these. But obviously that line hasn't repeated everywhere else. So we're going to redo the pattern with that. And then you'll see that everything actually tessellates nicely. And you should be able to select this, create rectangular pattern, space it out. I believe the number we want is 15.4. Enter. Get rid of this. And then all you do is you select this, coincident. And then, oh, I was silly. I didn't do this properly. This is meant to be 10. And then we go over to here and we just want to select that and make that horizontal vertical. And there we go. All we need to do now is press E for extrude. How tall do we want to make it? Well, how tall is everything else here? It's all 1/2 inch. So we're going to put 12.7, enter. And there we go. That's our little rack. So now we can save this. And so now we've made our body. We're going to go about making it a component. What are we going to name it? Let's think really hard. Well, it's a rack, so there's no pitch diameter. It's like infinity. Well, we still know the module, and we do know the number of teeth. And those might be useful, so we'll just put those in. 5mm pitch, module. And 10 tooth rack. And oops, oh, it looks like I've made it in the wrong folder, which is a convenient mistake that I've done on purpose so that I can show you how to move things in Fusion. So here it is, and then we can right click, move, and move. And then Fusion is going to take forever to sync. Now, one of the best ways you can speed up this Fusion syncing is by switching on offline mode. I'm kind of scared to do that because I really appreciate the autosaves, because at the moment, this virtual machine is very volatile. And let's drag it in just like every other component. And easy peasy. Just like that, we have made it 3/5 of the way through. And I'm just kidding. It's not 3/5. It's more like 80%, because the next two stages are actually quite quick. So what will happen now is we're going to go and do joints. Now, joints are the love of my life. I love joints. Assemblies, this is the part that I yearn. This is the part that gets me out of bed in the morning. It's fantastic. Oops. Yeah, never mind. So we're going to switch over to here. And we've got all of our different parts floating around in this model. And the first thing that I'm going to get you to do is pay attention to this timeline down here. Now we can drag back the timeline. I'm going to just click on this and drag it. Or if that's too laggy, you can just press all the way back to the start and go one forwards. And what we're going to do is that we're going to make sure that we pin the first component in our timeline. No matter what assembly you're doing, every single assembly file should have the first component pinned. And generally, you should make sure that your first component is like a significant one. You don't just want like a spacer or something to be your first component. You want it to be like a chassis rail. So we're going to go in here. And the way that we pin something is we right click on it in the browser. There's nowhere else you can right click on it. You can't right click on it down here. You right click in it in the browser and you pin it. And magical, you see this little pin down here? Worlds of joy from me. If I see that in your models, I will be very happy. And so now we can go forwards one at a time. So we have this gear that we brought in, and we're going to press the magical button, J. Look at that menu. It is just beautiful. So we're going to select this bottom line, and then we're going to select this line. And look at that. Instead of having to use the move tool and kind of fudge things around, it just works. So now we can use, say, Revolute, and you see how this starts spinning. Or you can use like different types here. Explore, have a try out. You know, you see like cylindrical, and it's like, whoa, it's moving in all weird ways. Or you can even do like ball, and it's like, yeah, that's broken. That's not working properly. And you can even see like with rigid, it shows you that like the two parts will like shake together. And something I want to show you is also what happens, like all the ways that joints can go wrong. So I can press J and then like, oh yeah, I've clicked on this face. And something that can be kind of confusing is that often it's not one click to select something. It'll be one click on a face, and then it wants you to select a snap point on that face. So you can see how as I hover around, my snap point moves on this face. Or like I can move, excuse me, or I can move it to the center. And in this case, this will actually still work, but it might be going through your part. And then you can try messing around with flip, and you'll see that there's always ways around it. Anyway, so I'll just do this properly. Select that line, scroll over, and pan over. And then I'm going to select this line. And then, is it Revolute? Let's make it Revolute. Cool. Next component. You can see like joints, like they're really quite easy. Once you have components in this structure, everything works. The worst thing you can do is doing joints in an assembly that doesn't have the pin put in, or like you're trying to do joints between bodies and components and things are breaking and Fusion's getting angry and your timeline's full of yellow and red warnings. If you're doing it this way with like the multi-file structure and you're just dragging in components, it works flawlessly. Unless you have like a million joints. That's a separate thing. If you're doing like massive assemblies, you can get Fusion to panic sometimes. But generally, you won't run into that issue. You should be fine. So on to our next component here. I don't think there's any surprises. We are just going to J. Oh, where is it? J. And we're going to orbit until we can access that line to click on. And then we're going to zoom in, click on this other line. And just like that, Cool. But something doesn't look right here. I don't think these gears are working. And like, if you remember from the start, when I pulled up my original model and I was able to just like drag one part and they both spun. Well, what happens if I click on this? Nothing happens. What is, like, shouldn't it be working by now? Like, doesn't like Fusion's cool, like a smart piece of software? Doesn't it do like simulations or anything? No. Fusion is incredibly dumb. So what we're going to do now is actually skip ahead a tiny bit. I'm going to jump back and forth between these fourth and fifth stages. And we are going to do motion links. This is the like my bread and butter. I love motion links. So we're going to go back into Fusion. And the way the motion links work is you go into Assemble, Motion Link. I know, pretty hard, like tough. And then we're just going to select one and select the other. Like, I'm not even holding down Shift. I'm just clicking these. And would you look at that? They're moving. But I still don't think it's moving properly. If we like, yeah, that's not really working right. So obviously we're still doing something wrong. Let's go back into motion links. And, oh, it's not animating when I do this. What if I, there we go. And so you'll notice here how there's like angles. Well, this is the ratio between your gears. Now, how do you find out the ratio? You divide the teeth by the teeth. So in this case, it's like there's I can't remember the formal thing. Like if you're on a bicycle, it's teeth front over teeth rear. Oh no, teeth driven over teeth drive. I'm running off the top of my head. In this case, we know one has 7 gears, 7 teeth, and the other has 14 teeth. So it's going to be a ratio of 2. So I'm just going to brute force. I'm going to say it's probably going to be like 180. Something's still wrong. I wonder what this button does. That's looking more like it. That's like really close. But if you tried to make these gears, I don't think that's gonna work out for you. You might end up like with some explodey bits if they're trying to get inside each other like that. So what we're gonna do is, before we do our motion link, there's actually no way. So like, sorry, rewind 10 seconds. What we want is for like these to be meshing perfectly. Like we want them to be like this. Where is it? If I zoom all the way in, it gives me more accuracy, I think. Never mind. Yeah, so we really want our gears to be like this. But there's no way for me to do that after the motion link, because like if I try and move them to a line, they always move together. So the way we fix this is that we need to do it before our motion link. So I'm going to do what I just did. I'm going to rotate this until it's what, -11, and that made it work. No, -12. And then we're going to do our motion link when they're already meshing properly. So you need to sort out the meshing before you do your motion link. We're going to go in here, press that. And then it comes up with this dialog box. Capture position is what we want to do. And then we can select this joint and this joint. It still doesn't look like it's working properly. Let's try putting in those numbers that we knew previously. There we go. So now you can drag on this and they just mesh perfectly. And it's just beautiful, beautiful, beautiful. So let's move on to the next part, which is our rack that we had. Which was it? This one. So we can skip forward in our timeline. Oh, we have two of these. That's a predicament. Let's just delete this one. And we can skip forwards to when the rack comes in. There we go, the rack's over there. So we're going to press J for joint. Just like this. And oh, it hasn't actually selected yet. We need to choose our snap point. So I'm going to choose this bottom edge. And then we're going to select this line. And we need to select our snap point. I'm going to choose this bottom edge. Yeah, that's not the motion we want, is it? So we're going to go into here. We're going to change it to slider. And there you go. Suddenly it looks a lot more correct. I mean, like shift this along. And now what I'm going to do, I could do a capture position, but I think there's another way I can get around this. I might be able to just add an offset until they line up perfectly. So where is it? Oh, it's like this one. I'm going to make it 15, 35, 36, 37, 38. Oh, so it's kind of like 38. That's going to be 38.5. 4. There we go. It's like right in the middle. But we have a problem. They're kind of binding. You can see that. So before we fix up our motion link, we do need to fix that binding. So we're going to go and open our original file. And then we can go into our sketch by double clicking on it in the timeline. And we never actually defined how thick this is. So if we go in here, actually, I'm gonna give this a thickness in here. So I'm gonna define it. Let's say, okay, that's what it is now. And then I'm gonna go into this model. I'm gonna select this line and this line. I'm gonna press, actually, I don't even press anything. I can see down here in the corner that Fusion is telling me they're currently 0.3 mil apart. So what I'm going to do is I'm going to decrease this by 0.3 mil. So I'm going to make it like 7.8. I'll give it a, actually I'll do 7.7 so it has a little more room for backlash. Actually no, that's, yeah, technically for backlash, yeah. And now I'm going to press Control S, save. And now that I've saved it in there, you'll see up here in this corner that I have this little sign. Now I need to be careful because I know my backplate got saved in a weird state. When I click on this, it's going to you can see it on the text, update two child components to their latest non-milestone version. So I'm going to open backplate and I just need to scooch the timeline over to the end. There we go. And I can hide that sketch. And Control S on this file as well. I'm going to wait for that to upload. And then I can go back into here. And once everything is uploaded, I just press this button and everything will update. And you can see how that's moved in a little bit. Now let's check from the top view if that is still binding. That is definitely still binding. Yeah, at this point, I might just need to guess numbers. So let's say I'm going to take it down to let's give it 7.4. Well, 7.4. Finish sketch. And now I'm going to change to working offline so this syncs faster. And I can press Control S, saves immediately. I can click this and see it updates like really quickly. And clearly that wasn't enough, so let's go back in here. And let's change it to like 7. Finish sketch. Control S. And go over to here. Update. Oh, not quite there yet. Add a little more. 6 point, let's say 6.7. Finish sketch. Control S, move over here, update, and there we go. Now they're meshing nicely. I think in reality, you'd still run into some issues because you can see it's binding there. So I decrease it just a little bit further. Let's take it down to 6.5. And one final save, update. And there we go. Now it's running nicer. So let's rotate. Oh, rotate wrong way. Now we're on to the final home stretch. We're going to do our motion link. So let's go into assemble, motion link, and then we're going to do it between this joint and this joint. Now let's see. Yeah, at the moment it doesn't know what it's doing. But if we go in, and I think we just need to fiddle with these numbers. I might set this like 3, I think. What if I make it, I might do some rough maths. So there's 14 teeth on this gear to do 360 degrees. So I can divide 360 by 14. If I just do calc. Let's do 360 divided by 14 is 25.7. This should move however long one of those teeth is every 25 degrees. So let's try that. I'm going to set this to 25 degrees. And then roughly how long do I think one of those teeth was? I don't know. I'm going to give it like 15, like 14. I'm going to say it's okay, and I'm going to go back and check that actual distance. So from one point to another, 15.4. So let's set that to 15.4 every 25 degrees and animate it. And there we go. The only problem was I need to click on reverse. It was just hard to see because it's running really quick with the animation. And just like that, we have our fully finished assembly. And you can click on this and see how all of it moves really nicely and everything meshes the whole way. It's pretty neat. So, congratulations. You have succeeded, hopefully, in the trial by fire. If you did this all in one session as your first time doing CAD, you've earned it. I hope you now stand up and get some blood flowing. Because we have stage 6 that we're going to go into. I'm just kidding. So what mechanisms will you actually be CADing? Generally, this is the best place you should go. First stop, check this out. They have just about every important FRC mechanism. It's a really, really cool catalog of designs. Like better than I could ever show it. In actual practice, what you're mostly going to be doing is, and this is more on the design side, but you're going to be defining endpoints. You'll have like some sort of driving point where you have a motor, and you'll have some endpoint where you need to drive an axle or something, and you'll need to be CADing gears or like doing belt runs and the like. For the most part, it's like either like making frames to hold something in a position, or making mechanical like runs where you might have like 2 gears that need to mesh because you need a reverse direction, etc. And now a surprise for our EMU students. This is a bit of a social experiment, and it's one that I've been mostly responsible for trying to push. I think the best way to cement your CAD skills isn't a 3-hour workshop. A 3-hour workshop will get you introduced to it, but if you wait 6 months, it's going to leave you. To me, to really feel confident in CAD, you need to take on a big assembly. which is what I want to get you to do using this. Now, the money isn't the real incentive. That's just a little bonus I want to throw in because I personally think 14-year-old me would have found that pretty cool and fun. These robots are slowly becoming lost media. We only have so many photos of them. We did some recent work to collate them, but we'd really like to have some CAD models so that we can use them for marketing and to look into them in the future. And what better way to do that and develop student CAD skills and get a little bit of competition going in the team than with a CAD Bounty? Obviously, some of them I mentioned there. Important one I'd like to mention, resume scale project. Scholarships would love this sort of thing. And even better, scholarships would love it if you develop your skills with this and then go absolutely crazy in 2025 and 2026 and 2027 FIRST Robotics seasons. I will say there are some conditions. This is to level the playing field because I know we have students of many different CAD skill levels. And of course, I'm holding you to a high standard. That's another one of the reasons why I like the bounty, because it's not just a project where the finish line is kind of vague. Your finish line is when you get that gift card. And if you don't meet my standards, you don't get that gift card. I'll happily explain what you're missing out on and I'll help you get there, but it's to give you that solid defined threshold. And one last thing, this does not set a precedent. This is $500 of my own money that I'm putting forward to do this. I don't like the idea of using the team's money for this because it's not essential spending. But I'm still choosing to put my money into it because I think it's a really worth it investment in the long term to be able to show you guys that connection between, oh, wow, my skills are actually worth money. And so that you can really take pride in knowing that you are producing something that is super high quality. I know in high school, once I got that feeling of pride for producing work at high quality, it was addictive and it stuck with me. And it was one of the things that got me to spend endless hours, like way too many hours doing work in my high school years. And that's really what I'm trying to kind of invigorate in you guys. And I also just come back to the fact that I think like 14-year-old me working $8 at Domino's would have thought this is the coolest thing ever. But that's outside the point. I want you to make use of this opportunity and I want you to make use of it soon so that you have these skills to benefit the team ASAP. And now the final thing in this slide deck is this incredibly good Fusion Tips video. You'll watch it and in 20 minutes, you'll suddenly be like, I actually understand everything that's happening here. I was going to show it at the start, but I think it would be too much too quick and none of it would actually stick. But now that you've spent time working with it, you'll see everything here and you're like, oh my gosh, it's all in one place.
In this video, I'm going to show
you 50. You can get an idea of the pacing. It's a really well-paced video.
To know.
And this is just a little bonus thing, like an anecdote. 2.5 years ago, on my first season with the team, I took the initiative to learn Fusion 360 with the help of Joel over my shoulder, and I can't emphasize how far it ends up taking you. Like, as you already know, it's my job. It's helping me out at uni. But it also has some really quite touching sides to it. It was really special being able to have the opportunity to do all this stuff because I'm the technical lead. And yeah, I think I'm just about there. It's like 11:30 and I've been doing this for probably like 5 hours, and it's been like 25 hours of prep up to this. And I would like to put even more time into this to make it more refined, but I need to be honest with myself that I just can't afford to spend more time on this CAD workshop. I'll happily fill in any gaps in person. And if you have any questions, just reach out.
Am I insane, or is it now the normal way? Reasons out, just hope and pray, and switch off till it goes away and kill my brain. It's all I crave. I'd rather have a stupid day instead of feeling like a fake, an afterthought in the ashtray. So this goes on and on, yeah, it goes on and on. No more space, hit replay, yeah, it goes on and on and on Another time, the neighbors acting like we're fine. Had a party, paid the fine. Man, it kept me up all night, just having fun. What's so wrong? Celebrating like we won. Sex, we're still on season one. I guess we'll fake it till we make it. Then it goes on and on. Yeah, it goes on and on. The latest craze, can't relate. Yeah, it goes on and 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 Feeling sick, the weekend never seems to end. As if the circumstance all changed. Set a fire to your stage. So this goes on and on. Yeah, it goes on and on. It wouldn't die even when I tried. And it goes on and 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 on and
Stop.
emotional. It's what I always wanted. Could never have too many things. Will you quit kicking me under the table? I'm trying, will somebody make us shut up about it? Can we settle down, please? 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 have to move on or let go. Add to the memory you keep. Remember when you fall asleep. Hold to the love that you know. You don't have
Don't you water me down, 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 down. Don't you water me down, 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 down. Not enough therapy to make me close my eyes. I'd rather lose control than keep it inside. Don't you water me down, 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 down. I've been lying to myself. I feel stranger when they're all around. There's nobody in this world, nobody I know, who ain't dying just to play a part. Struggling to my feet, still jaded, heart breaking into pieces. They say it's only me, not waking up. Don't you water me down, 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 down. Don't you water me down, 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 down. Not enough therapy to make me close my eyes. I'd rather lose control than keep it inside. Don't you water me down, 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 down. Don't you water me down, 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 down. Not enough therapy to make me close my eyes. There ain't all of the words that could change my mind. Don't you water me down, 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 down. I'm relying on myself. I don't care what makes them safe inside. I'm done waiting for the proof. I'm waiting for help. There's no question that we're in the dark. Nothing left to believe. Not waiting till there are a lot of reasons. They say it's only me. Still waking up. Don't you water me down, 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 down. Don't you water me down, 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 down. Not enough therapy to make me close my eyes. I'd rather lose control than keep it inside. Don't you water me down, 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 down. Don't you water me down, 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 down. Not enough therapy to make me close my eyes. There ain't all of the words that could change my mind. I used to worship you. Now I'm just left to myself in all this room where something lived. You centered me. My center was you. My sun and moon. My sun and moon. A daisy moves when it learns the root didn't have the hold that it used to have. The spiral shrine, we all aligned. The spell wore off. I'm not in love.
Is anybody here with your family, like your sister or your brother? Is anybody here with your best friend? Is anybody here with a team more than like 20? Make some noise right now!
Still here with the ones that I came with. Still here with the ones that I came with. Still here with the ones that I came with. Still here with the ones that I came with. Still here with the ones that I came with. Still here with the Still here with the ones that I came with. Back to the shadows, rolling back my eyelids. Please don't leave me like this. Get into the night,
Please don't leave me like this.